let's talk about something you do literally every single day, looking at things. But we're not just talking about a quick glance. We're going to see how the simple act of looking transforms into a really rigorous engineering discipline. It's called visual testing, and it's actually the oldest and most fundamental way we make sure the world around us, well, doesn't fall apart. Let's get into it.
You know, we all use our eyes to check things out. Is that tire looking a little flat? Is this milk still good? But when we're talking about engineering, visual testing, or VT, is so much more than that. It's a formal, scientific discipline grounded in physics and some really strict standards. So yeah, while it's probably the most common inspection method out there, it might also be one of the most misunderstood.
Okay, so to really get a handle on this, we need a proper definition. What's the actual line between a professional visual test and, just looking at something?
Now check out the wording here because it's really interesting. It doesn't just say using your eyes, it says electromagnetic radiation in the optical range. That's just the super scientific way of saying light. This official definition is what makes VT a true non-destructive testing method, putting it in the same league as things like X-rays and ultrasound. It's all about applying the science of light in a very structured way.
And don't ever think that because it's simple, it's not important. It's actually the opposite. In the world of non-destructive testing, or NDT, visual testing is pretty much always the first thing you do. Before you bring out any of the complex, expensive gear, a trained inspector uses their eyes. You can think of it as the first line of defense, the main gatekeeper for quality and for safety.
So if it's all based on the science of light, what does that actually mean when you're out in the field? Well, to really get VT, you've got to understand the basic physics that makes the whole thing work in the first place. Think of it like this. The object you're inspecting, say a metal beam, it doesn't just send out a signal that says, "Hey, I'm cracked." What happens is light bounces off its surface. That light is the energy, and it carries information to the inspector's eye, which is acting like the primary sensor. Then the eye and the brain work together to process that light and figure out what's going on with that surface. It's a really simple, elegant system. You've got the energy, the object, and the sensor. Okay, but if the eye is the primary sensor, that brings in a huge variable, doesn't it? The human being. Not all sensors are built the same, right? And that's exactly why the field of VT puts so much focus on standardizing the inspector's vision. We call it visual acuity. We have all heard the term 20/20 vision, but what does that fraction actually mean? It's not a percentage, it's not a score out of 100. It's a very specific measurement that compares your eyesight to a standard. This table breaks it down perfectly. The top number, the 20, is your distance from the eye chart, which is usually 20 feet. The bottom number is the interesting part. That's the distance where a person with normal vision can read the exact same line. So if you have 20/40 vision, it means you have to stand at 20 feet to see what a person with standard vision could see from all the way back at 40 feet. And you better believe visual inspectors have to meet really strict standards to get certified. And hey, it's not just about seeing things far away. Inspectors are often working right up close, looking at welds, reading tiny little gauges, or searching for hairline flaws. Because of that, their near vision is just as critical. So it's tested at a standardized distance of 400 millimeters, that's about 16 inches, to make absolutely sure they can see the smallest details right where it counts. But look, even the best trained human eye has its limits. That's where the tools of the trade come into play. They're designed specifically to enhance and really extend the power of our own vision. The toolkit starts with the real basics. We're talking simple magnifying lenses, usually between 2 and 5 times magnification, just enough to help really find cracks or surface issues pop. Then you've got specialized tools like welding gauges and gap gauges, which let you take precise measurements. That's how you turn a qualitative look into a quantitative, hard data assessment. These basic tools are fantastic for surfaces you can get right up to, but what about the inside of a pipe, or deep inside an engine, or say, the core of a nuclear reactor? How do you see in there? Well, for those jobs, we have remote visual inspection tools, and one of the most important is the video scope. It's basically a long, flexible tube with a tiny camera and its own light source right at the tip. This lets an inspector guide that sensor deep inside a component and get a live video feed of areas that would be totally hidden otherwise.
And things can get incredibly sophisticated. Just look at this thing. This is a remote camera positioner, a robotic system used for huge industrial inspections. You can see it's got winches, extension tubes, a camera that can pan and tilt. This is not just a camera on a stick. This is a complex machine for systematically inspecting critical, hard-to-reach places.
This cutaway of an industrial valve is the perfect example of why these tools are so essential. An inspector can't just unbolt a massive component like this to take a peek inside. That would be a huge, costly, and time-consuming job. But with a video scope, they can just navigate through all the internal passages to check for wear or corrosion without that massive teardown.
So, we've covered the science, we've covered the human sensor, and we've covered the tools. But let's tie it all together and talk about why this highly developed science of looking at things is so unbelievably important.
You know it's a big deal when it's all formalized in industry standards like the ASME code. Visual tests are actually broken down into different categories. VT1, that's for that really fine detail surface inspection we've been talking about. But then you have VT2, which is specifically for finding leaks. And VT3 is more of a broad, general checkup of the overall structural and mechanical health of something. This just goes to show how diverse and critical the role of VT really is.
And really it all comes down to this. This is the mission statement from the American Society for Non-Destructive Testing. Every single standardized vision test, every precision gauge, every remote video scope, they all serve this one ultimate purpose: creating a safer world. It's about finding that small problem before it has a chance to become a catastrophic failure.
So the next time you find yourself driving over a bridge, or flying in a plane, or even just flicking on the lights at home, take a second and remember what you don't see. The safety and reliability that we all pretty much take for granted are built on this silent, meticulous science. It's a discipline where a trained human eye, guided by the laws of physics, is still our first and most important line of defense.